Hi students, welcome to physics class. In this video we will discuss about variation of acceleration due to gravity g with altitude, that is height. We know that the acceleration due to gravity is a constant one whose value is g is equal to 9.8 meter per second square, while the acceleration due to gravity varies from place to place on the surface of earth depending on the factors like altitude, latitude, depth and shape of the earth. The variation of acceleration due to gravity value is relatively small and they play a significant role in situations such as satellite navigation and some scientific experiments. We will derive how the acceleration due to gravity g varies with altitude, that is height. Let us consider an object is situated at this point and the mass of this object is small m and the mass of earth is capital M because it is a huge body. From the relation between acceleration due to gravity and the universal gravitational constant capital G, we can write small g is equal to capital G capital M by r square. Here small g value which is written here is the acceleration due to gravity at the surface of earth, that is the acceleration due to gravity of this object which is on the surface of earth is given by this expression. Now let us consider another object which is nothing but a satellite which is orbiting around the earth at a height of capital H. Then we can write the acceleration due to gravity g for the satellite as capital G capital M divided by r plus h whole square at height h. Here we can clearly observe that the acceleration due to gravity g value does not depend on the mass of the object. Let us say here small m is the mass of the object on the surface of earth. Let us say m dash be the mass of the satellite. In the expression 1 and 2 we will not observe any mass term related to the object or satellite. Now from these two equations we can write, let us say the acceleration due to gravity at height h is g dash. Then by dividing equation 2 with equation number 1 we get capital G capital M by r plus h whole square divided by G capital M by r square. Here we have written r plus h whole square in the place of r square because the distance of satellite from the center of earth is r, that is the radius of earth, plus h, the height of the satellite from the surface of earth. which is equal to r plus h. By cancelling the similar terms, we will arrive at g dash by g is equal to 1 by r plus h whole square divided by 1 by r square. Finally, we get g dash by g is equal to r square divided by r plus h whole square. Next, g dash by g is equal to r by r plus h whole square. Next one, by reciprocating this fraction, we get r plus h by r whole to the power of minus 2, g dash by g. Therefore, g dash by g is equal to, by dividing with r, we get 1 plus h by r whole to the power of minus 2. Now move the g term to the right hand side, then we get g dash, the acceleration of the satellite at height h, is equal to the acceleration of object at surface of earth into 1 minus 2h by r. Here we have written this expression as 1 minus 2h by r because by the binomial theorem we can write 1 plus x whole to the power of minus n as an approximation of 1 minus nx. This is the final expression for the acceleration of the satellite or the acceleration of object at height h, which is equal to g dash is equal to g into 1 minus 2h by r. And we will plot a graph taking distance on x-axis, acceleration due to gravity g on y-axis, then let us say this is the origin of earth and r is the radius of earth, then this is the surface. When we move from the surface of earth to a distance, then we can observe the acceleration due to gravity g value decreases. This can be observed in this expression with a minus sign, that is g dash is equal to g on the surface of earth minus g into 2h by r. G into 2h by r factor is responsible for the decrease in g value.